Hey everyone, this is a project deals actually with the research paper semantic search. The architecture is as you see on the screen. We have a query that this is a Streamlit that has the same process that actually takes place. But just to view in the Google Colab, written basic code that actually requires for exploratory data analysis and doing some research. But the same code has been used to build the Streamlit application. But the workflow looks like, we have the arXiv papers from the data is taken from um, Mr. Martin Rutenberg, actually the author of a hands-on LLM book. So basically, that has the titles, the abstracts, and it has more, but I've just used the query here to filter a few papers based on the keyword that is attention. But if you take out this query, it has lots of information, lots of uh, uh, titles and abstracts from various papers from maybe it's around 25 years, I'm not pretty sure, but it's available till 2025. So the architecture looks like this. We do the dense search, and there is also the lexical search that is actually sparse search. This is purely based on keyword search. The dense search is uses probably an approximate nearest neighbor, and we just compare which results are much better. The optional one that is also implemented in this is the hybrid only approach, where it implements the choosing the candidates from both dense search as well as the sparse search, that is lexical search, and it combines both the results, and whichever has the highest relevance gets chosen as the appropriate paper to look for, which is more relevant based on the abstract or keywords or any sentence that you can put. The good thing about this architecture is also that the data is stored um, in the vector database by using Chrome DB, um, and it is selected based on the re-ranking after the search has been done. And then one addition to make it more look agentic is we have put an agentic function, a small pseudo agentic, which I could say that is the DuckDuckGo search option. It uses the search engine DuckDuckGo and gets the tries to fetch the paper that is available and get the link and tries to open the link. If the paper is not available, it just shows that the paper is not available, or maybe it could not search the paper or get the link. The notebook kind of covers most of the information, a basic information and which model is used. The here the dense search of the paper, I mean, based on the paper's abstract, the dense search is done, and you can see this is one of the abstract or maybe the query, and it tries to fit with the score, that is this paper makes more relevant and has the 0.85, that is highest score. The sparse retrieval that uses BM25 algorithm is basically the keyword. It uses the keyword search, which was happening before um, the dense search was even like implemented, or maybe even Google was using keyword searches before to show up the websites. The same paper, if we search, but if you see the BM25 is not actually more accurate. BM25 uses the distance metric, so basically we should go for the lowest distance, that is 20 than 25. So this is not the paper that is actually more relevant. It's basically the revisiting dynamic evaluation, but still it doesn't make sense, but which is why we have the hybrid approach, which is implemented in the Streamlit application that is over here. But just to test out, this is a re-ranking logic, and based on that we just got the more relevant for this particular query, that is effective adaptation of large language models for low data regime. It has the highest score. Well, we're moving from FA. This notebook shows FAISS, which is actually Facebook developed it metric, but that is good for testing. Basically, that prepares a vector index, but it doesn't do have a vector database. It's good for research when you're doing like collab, but if you want to go production wise implementation, I chose Chroma, which is free and open source as well. I mean, it has a free version which you can implement. Uh, you can check out that actually in the Chroma website, the Chroma DB actually. And once that the embeddings are stored in the Chroma database, you can query similarly the way you query normally with how we did in the re-ranking step. You can see that has um, that shows the more relevant paper which is related to this, that is end-to-end attention distance speech recognition highway LSTM. So and this, we can check out uh, the paper ad hocly, but before that it uses an additional step that I just mentioned in the beginning of this. So which is like, it gives, if you give the 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 query which has an abstract or a sentence that is related to the paper, it tries to fetch if this is available through internet. And if you see this, the output, it has a snippet that has the kind of a snippet of the abstract, and then gives a link. And if you extract the link, you get this link. This is actually the paper's link. If you remove the ABS and somehow update from, change the string from ABS to PDF, this complete link works as if it opens a PDF. So, and this is just a notebook, but if you try to implement this pure code into an built into a UI, this looks in like just like this. But just before that, let's try to see if we can get some paper. I had to see something that has an attention. So let's see this one. It has this paper. I'll try to see if we can get the abstract from there. Has this, get this. This is the same abstract actually that's available here, I guess, the many of the current. Yeah, so if you take this and ask the ChatGPT and just um give a one line summary of for the below abstract, tries to give the paper presents an HHM or something like this. If I try to copy this, and if I go here, let's say if I give, I'll show the metrics and then select hybrid re-rank, select this, and then try to search. It gave the end-to-end attention distance speech recognition highway. That's the highest score. Is that the paper name? That's the correct paper name, but will it be able to fetch the paper from internet? Let me close this. Let me go down, search for the internet for paper. Paper found. Can it open? Yes, it directly opens this from the PDF, and this is the same paper that we just looked into, so this kind of works. That we have the repository for this, which is pretty in detail, and also has a link for Google Colab that is shared in the notebook. Give it a try. It has architecture diagrams and detail how to work through the repository, how to install all the libraries, and how to keep it running. um, so the and you can get more information and get the papers from this um, arXiv. This is the data, and this is the link of the dataset, which is from the Hugging Face. Yeah, so that is about the project.